video tutorial, we are going to explain about reader-writer problem. Actually, what is reader-writer problem? In this problem, we have number of readers and number of writers. So, what happens when we have one shared file, and from this shared file only readers can read and writers can write on this shared file. Now, if a reader is reading from the shared file, no other writers can be allowed to write from the same file. Only other readers can be allowed to read from the file. Like we can have reader 1 and reader 2 simultaneously reading the file. But we can't have one writer writing the file at the same time when readers are reading the file. So when readers are done with the reading, they left, then writer can come and change the content of the file. So when writer is changing the content of the file, no other writers, no other readers are allowed to read the file, or no other writers are allowed to write on the file. So when one writer is finished writing, the other writer can come and write, or other readers can come and read from the file. This is the basic scenario which is in reader-writer problem. So now Pankaj will be explaining about the practical scenario. So thank you.
So as you have already seen the introduction of reader-writer problem, so here I have to further explain the reader-writer problem using a physical scenario. So here you can see that we have assumed that this is a share file, and we'll be using only 3 readers and 1 writer for the simplification of the problem explanation. Here we have 3 readers, reader 1, reader 2 and reader 3, and only 1 writer, writer 1. Now suppose reader 1 wants to come and read the shared file. So as nobody is writing, means the writer is not writing, so he can come and read from the shared file. Now as you can see, the reader 1 is reading. So if the writer wants to come and modify the file, so he will see that reader is already reading from the file, so he cannot modify, so he went back and sit at his place. Now at this moment, if reader 2 wants to read from the same file, so he can come and read. There is no problem in that. Yeah, so as you have seen that reader 1 and reader 2 are already reading from the same file. Now reader 3 can also come and read from the same file. And let's suppose reader 1 has finished reading from the file, so he can went back and sit at his place. And in the same way, reader 2 and reader 3 has also finished, so they can also go and sit at their place. Now as the writer was waiting, so he can now come and modify the shared file. So at the moment, writer is modifying the file, and now suppose the reader wants to come, suppose the R1, reader 1 wants to come and read from the file. So he cannot do that because at this moment writer is modifying the file, so reader is not allowed to read from the file. So now writer is writing and now he is done, so he will go and sit at his place. So this was the explanation of the reader-writer problem using a physical scenario. So now in the next step we will show the code for the reader-writer problem.
So basically you have seen the physical scenario, how to implement it physically, the reader-writer problem. So now we are going to see how this reader-writer problem can be solved by using a semaphore variable. So we'll see the code for it. So by solving this problem by using the semaphore variable, we see here that we are using 2 semaphore variables. The first one semaphore variable is mutex, which has been initialized to 1. The second semaphore variable which we have taken is write, which has been initialized to 1. And now third variable will be an integer variable. that variable name is read count, and which will be initialized initially to value 0. So now coming to the reader process structure. So if any reader process want to read from the shared file, so first of all it will perform the wait mutex operation. So now as the mutex variable, we know that its value is 1, so it will be successfully executed. After that it will increment the read count value to 1. So initially the read count value was 0. So after execution of this particular statement, the read count value will be 1. So when the reader 1 came, so it incremented the read count value to 1. So here this if condition will be satisfied. Now it will perform the wait write operation. It will be successfully executed because the write is a semaphore variable and it has been initialized to value 1. Now after this, the signal operation mutex will be performed. Now the reader 1 process, after performing the signal mutex operation, will come here, and now from this point onwards it will start reading the shared file. So when the reader 1 process is reading the shared file, since signal mutex operation has already been performed, now the other reader process can come here and can also read the shared file. So in that process, the reader 1 will come, reader 2 will come, reader 3 will come, reader 4 will come. So like that, the reader will come and read the shared file. So now after, suppose the reader 1 finished reading the file, so it will perform the wait mutex operation. We all know that the wait mutex is a semaphore variable and its value is 1. So now when it will perform successfully. After that, each and every reader process while coming out will decrement the read count value by 1. So at the end, if the read count value is 0, then only the signal write operation will be performed. And when this read count value will be 0, it will be done 0 by the last reader process which is going to come out. So then only the read count value will be 0. So now after that it will perform the signal mutex operation. So as you can see over here, like the first reader process, when it enters in this region, it performed the wait write operation. So basically what it did, it blocked the writer process. So if any one of the reader process is reading the file, so it basically performed the wait write. So when the writer process will try to perform this wait write, it will not be successfully executed because the write value has been initialized to 0. So the writer process can't write. So we'll come here, reader process. So when the writer process can write, when all the reader process has successfully executed, has successfully came out, and signal write operation has been performed. Once the signal write operation has been performed by the last reader process which is going to come out, then only this wait write will be successfully executed by the writer process. So once this wait write has been successfully executed by the writer process, writing can be performed by the writer process. Again the signal write operation will be performed, and after that, if again the writer process want, it can come and write the data or change the content of the shared file, or the reader process want, it can come and read the content of the file. Okay, so this is what the basically overall code of the reader writer process. Thank you.
Okay, so the solution given for the reader writer problem does not solve the problem of the starvation. Okay, now what is starvation? So starvation is a phenomenon in which let's say some agent has to wait for some infinite time. In our reader writer problem, we can see as let's say one reader has arrived and he is reading from the shared file. So now writer has to wait as reader is reading. So writer is waiting and reader 1 is reading. Let's say reader 1 is reading. Now one more reader arrives. So reader 1 and reader 2 are reading. Writer is waiting. Alright. Now say reader 3 arrives. So reader 1, reader 2, reader 3 are reading and writer is waiting. So in this way, reader will simply keep on arriving, whereas writer has to wait. So this is the condition of starvation for the writer, because writer is not getting chance to write at all. So this thing is called starvation. So we can also see this thing from the code. Okay, first we will go for the reader portion. Now let's say one reader is arriving. So initially our mutex is 1, so wait mutex, after this wait mutex will become 0, so my mutex will become 0, so mutex will become 0. Okay, read count is initially 0, so read count equal to read count plus 1, so read count will become 1 now. As read count is 1, it will put write on the wait condition, that means write will become 0. Oh yeah, fine. So as write has become 0, so writer cannot enter into the writer code, I mean that portion, and it cannot perform its writing. So writer is in the waiting condition. Writer has to wait here only. It will keep on looping. It cannot enter into the writing portion. Alright. Now as reader has successfully entered into this critical section, so reader can start reading the shared file. So reader will perform the reading. Alright, now let's say one more reader enters. So the reader will enter inside this, then read count will again increase, read count will become 2, and then again it will go inside the critical section and it will perform reading. Let's say one more reader comes, so again reader count will increase and it will enter into the reading section, critical section, and it will start reading. So in this way, reader are simply arriving and they are performing their task, whereas writer is simply waiting in its critical section, in the loop. It is simply looping. Okay, now this condition is called starvation. Okay, so to solve this problem, what we can do, we have to modify this code. We can put one more semaphore variable into it. Let's say read. So read is another semaphore variable. It will be a semaphore variable. We can assign the value according to us, like if we want 3 readers to, if we want the maximum of 3 readers to perform their task, and after they finish their task, then writer should be given the chance to write into the critical section, write into the shared file. So we can limit the number of readers which will perform their task. Like if that much number of readers has performed their task, then writer will be given a chance to write into the shared file. So for example, let's take 3. That means 3 reader can, maximum of 3 reader can read the shared file at a time, and after they have finished their reading, then writer will get the chance to write into the shared file. So I have assigned my semaphore variable read as 3. Okay, now coming to the reader portion, the code for the reader. So what I'll do, I'll put a condition here. I'll put wait read. So when I will include this portion after this wait mutex. So when first reader will come, then it will decrease the count of the read. So the count of the read will become 2 now. After the entrance of first reader, so count of reader will become 2. And let's say one more comes, so it will decrease by 1 more. Let's say one more comes, so it will decrease by 1 more. So it will become finally 0. That means after the entrance of 3 readers, my wait read will become 0. Okay. So the maximum 3 can enter inside it. If another one will try to come, let's say if 4th reader tries to come inside this critical section, then he has to go through it, and when he will go inside this wait condition, then as the read is 0, so it will simply keep on looping there. It cannot enter into the critical section. So this is how we restricted the number of reader to enter into the critical section. Alright, now coming to the writer portion, what modification I have to do here. Okay, once my writer has finished his work, then what I can do, I can put a condition here. If read is equal to 0, then signal read. Okay, so if read is equal to 0, then what I'll do, I'll increment the count of read, so I'll signal read and put a loop here. So I'm putting a loop here so that I can increment the count of read so that it can reach to its initial value. As the initial value of read was 3, so I should put a loop which should run 3 times. Alright, so we have solved the problem of starvation by just simply adding 3 lines into our codes. One here, putting wait condition for read, then here giving signal to the read, and putting a loop which should run 3 times. Alright, so in this way we have solved the problem of starvation, as we are simply allowing only maximum 3 readers to perform reading at a time, and once they are finished, then writer will get chance if he is waiting. If he is waiting, then he will get the chance, and once he is finished, then he will signal the read, and then again reader can enter into the critical section, and then they can start their reading.